Why do we still need to learn Git in 2026? This tool was created in 2005, so why is Git still around? I know that if you are already working as a software engineer or software developer, this question probably sounds silly. But what if you are a fresh graduate? Or maybe you are still in college and wondering, what should I actually learn to get a job in IT? My unexpected answer is Git. Hi again. In this video, I want to share my experience with Git and repositories. When I started working as a system engineer back in 2022, my work was very infrastructure focused. I spent most of my time managing Linux servers, installing applications, and deploying systems, all done manually. Back then, I thought Git was only for developers. I honestly thought, I'm a system engineer. Why do I need Git? But everything changed around 2025 when our deployment started moving toward microservices running on Kubernetes. Suddenly, my role was no longer just about managing servers. I had to work with CI/CD pipelines, container deployments, and version control. That's when I realized Git is not only for developers. It's a fundamental skill for anyone working in modern infrastructure, DevOps, cloud, or platform engineering. And honestly, I learned Git late. So in this video, I'll explain Git in a simple way so it's easier to understand. Let's get into it. So first, what exactly is Git? Think of Git as a project history tracker. It's the most popular version control system in the world, and its job is to keep track of changes made to your files over time. As projects grow, things change constantly. Bugs get fixed, new features are added, configuration get updated, and sometimes a change that looked harmless yesterday suddenly breaks something today. Without a way to track those changes, figuring out what went wrong can be painful. That's where Git comes in. It keeps a record of what changed, when it changed, and who changed it. That means you can compare different versions, go back to an earlier state if needed, and collaborate with other people without accidentally overwriting each other's work. How does Git actually work? Let's say you have a project folder on your computer. Maybe it contains script, configuration file, or deployment files, whatever your team is working on. Once you initialize Git in that folder, Git starts tracking it. At that point, the folder becomes what we call repository or repo. You will usually hear about two types of repository. A local repository, which live on your own machine or your own computer. This is where you do your day-to-day work and save your change. The other one type of repository is a remote repository, which live on a platform like GitHub or GitLab. This is the shared version that everyone on the team can access. So the workflow is pretty simple. You make change locally, save those change with Git, and send them to the remote repository so that the rest of the team can see them. And when your teammates make change, you simply pull those updates down to your local copy. So in simple terms, you work locally, your team collaborates remotely, and Git keeps everything in sync. Next, let's talk about some important Git commands commonly I use in my daily work and might be used also in the real project. As you can see here, there is some Git commands. There is a git clone, git branch, git add, git diff, git commit, git push, and git merge. These commands follow a natural workflow, so let me walk you through it. The first thing we must do is clone a repository from remote repository like GitLab or GitHub into our local machine. After that, we must separate our work from the main branch. We often use a git branch command. This is important because we are not make change into the main branch that currently used in the production or live environment. So we must avoid to make change in the main branch. After we create a branch for that, the next step we should change the parameter or the configuration file or whatever we are working on. And then after that, we check the difference between what we changed before and then after the change. After we review the change, we save it by git add and git commit commands and then push the branch into the remote repository. After that, the change can be reviewed and merged into the main project. This is like the approval or the reviewer by our lead engineer that sometimes need to make sure that we are not making a mistake. So these commands help me understand how teams collaborate and manage change safely in modern environment. So to summarize, we clone the repo, we create our own branch, and then we make change, review them, save them, push them to the remote repository, and finally merge into the main project. Let me show you a real example based on my actual work. So recently I work with a contact center platform that handles call routing, voicemail, and call recordings. The application runs on Kubernetes and the container images are built and deployed through a GitLab CI/CD pipeline. Disclaimer here, I'm not going to dive deep into CI/CD, container registry, Kubernetes, or YAML file in this video, or even how to build contact center. No, that's a topic for another time. But the point here is I will try to demonstrate why Git matters even for small changes. Here, as you can see, pods running in our cluster. This is our lab cluster, so this is for testing purpose. There are several components, but I want to focus on one that called SFCC. So the SFCC is the core application that handles call processing and calls recording. Let me show you the issues I tried to reproduce this morning. Yeah, so there are several exceptions, but I want to highlight this one. This exception tells cannot run program FFmpeg page, no such file or directory. This error tells us the application is trying to use FFmpeg page to process the call recordings, but the binary doesn't exist inside the container. So it means the container image doesn't have the FFmpeg page installed. So what we need to do is to fix the Docker file that builds the container image. To have better understanding, I will try to reproduce the issue again. So I will act as an agent and as a caller in the same time. Now I'm trying to call the contact center. It reached the contact center. It's arriving. Now I'm picking up. Test. Check. 1, 2, 3. Thank you. Yeah, as you can see here. So when the calls end, the contact center should record the interaction between the caller and the agent. But since we can see here the application cannot proceed to record the interaction because the ffmpeg is not installed. So I have already cloned the project into my local machine. This is my working directory. It's under livecom underscore sfcc. It contains Docker file, CI YAML file, and the source file that needed to build sfcc image. As I mentioned before, that we need to modify Docker file, so the container image will have ffmpeg installed and fix the issue we had before. I need to mention that our team uses GitLab as our repository platform, and I already authenticate to GitLab using personal access token or path instead of regular username and password. So I don't want to tell you about the details how to log in or authenticate to GitLab. You can find in another YouTube tutorials or just ask AI to guide you. Okay, so the first command we need to run is git clone. But since we already cloned the project, we just need to run git pull command. This is to make sure that we have the latest version from our team. So it's already up to date. Okay, next, we never change the main branch directly. Instead, we create our own branch for this fix. There are several commands to do that. There are git branch command, and then you can put the name of the branch, or you can use a single command like git checkout dash b and then the name of the branch. This single command is create the branch and directly switch to that branch, but I prefer to use git branch for this tutorial. And then you can put the name. In my opinion, if the fix is a temporary fix, sometimes we just name it, we categorize it as a hot fix before we get a major release, and then you can tell what the fix name. Fix ffm fix ffm page, fix at ffm page. Okay, the grid has been created. You can run git switch command. So this is to switch from main branch to the branch we want to have it as our active branch. Okay, and then you can just run git branch command to check the list of branch we have and which branch is active. So it's marked and I highlighted this one. You can also use git status command. Now we are going to modify the Docker file. As you can see here, the Docker file is using Alpine as the base image, and it uses APK to run installation of package or dependency that we need to have inside the Alpine image. So in our case, we just simply add ffmpeg in this line and then save the Docker file, and then after that you can just type git diff command. This is show us exactly what was modified. Worth to mention, in production environment, even a small mistake in Docker file can break the entire build. So reviewing the change before committing is a habit worth building. Okay, now once we are confident the change is correct, we can stage and commit it by using git add docker file. You can just check by git status command to see what is committed, and then after that we can commit by using git commit command dash m. This is for the message, that actually use if we try to merge the branch to the main branch for the match request. So this information is needed to tell what was changed for the merge to be applied to main branch. So we can type fix add ffmpeg page to sfcc image for call recording, just like that. Yeah. Okay, now we can push the branch to remote repository by using git push origin and then the name of the branch hotfix fix at ffmpeg page. Yeah, it's pushed now, so these branches are visible to our team and ready for review. After push the branch to remote repository, we will get notification about create new merge request to the main branch. Most people often use GitLab UI. As you can see here, if you open the project page, you will see notification to create merge request, but I won't guide you through these details. Instead, we are continue to using git merge command. Okay, now we need to back to the main branch first before we merge the branch to the main branch, and then we can just run git merge the name of the branch hotfix fix at ffmpeg page. Okay, so we just need to run git push origin main. Okay, that's it. So we can see the notification are gone here, and then the pipeline is starting to pick the job. So we need to wait until the pipeline completed, then we can continue to check if the sfcc now have ffmpeg page installed inside the container image. Once merged, CI/CD pipeline kicks in automatically. It tests the code, builds the new container image, and pushes it to container registry. And that's how Git fits into modern infrastructure. Once commit triggered, an automated pipeline that tested, built, and deployed a fix without anyone manually logging into a server. And this is our container registry. So as you can see here, this is the last image that we push with the latest tag image. Okay, once the pipeline is finished, we can check to make sure the SFCC is using the latest image that we updated in the SFCC Docker file. Before that, I want to show you the SFCC deployment. So if you already learn or know a bit about Kubernetes, you will find a parameter under spec.containers that's called image pool policy. This is set to always. That means whenever a pod crashes, get restarted or get deleted, the deployment will always pull a fresh image from the container registry. Also for this test, we are running the same tag on the FCC image, which is the latest. So I won't go into image versioning or continuous deployment in this video. You can check for yourself into other YouTube tutorials or YouTube videos, or just ask AI to explain you more about image versioning and continuous deployment. Okay, so now let's check what inside the SFCC pod to confirm that the FFM page is not yet installed, since the deployment is still just running the old image. Let's check the pod first. Now using exec command to go inside the pod. Oh, sorry, this one. Dash dash sh. So for checking the FFmpeg binary, if it's already inside the image, you can just type ffmpeg command with dash v for the version to check the version. Yeah, it's still not found. And also we can check what inside the logging file just to make sure this is the still the old image. So because I called some tests this morning. Yeah, they are still there. So yes, since the FFmpeg page is not installed and the log still show the same error about the missing FFmpeg page binary, so this is confirmed the pod still running with the old image. Alright, now let's delete the pod so the deployment does a fresh pull for the new image we just pushed to the container registry. So we need to exit the pod. Just run kubectl get pod dash n sdp platform. I forgot the pod name, so we can just delete it. Kubectl delete pod dash n sdp platform. This is the pod name. Hoopa. So we can confirm the deployment is trying to recreate the pod. Yeah, correct. 9 seconds ago. You can just confirm if the accepts this deployment is pulled the fresh image. Yet it's confirmed. So now let's check inside the pod. Oh, forgot the pod. Oh, this one. Kubectl exec this it this NSTP platform. This forget the S. Okay, we just try to run the ffmpeg command. Oop. Yes. So now it's confirmed that the pod is running using the latest image that we push, and the ffmpeg is already installed inside the pod. Now we need to test contact center functionality since we have ffmpeg installed. Before that, I need to go to logging properties of the SFCC application so we can just see. Oh, the details of the call, but just only to prove that the contact center will run the ffmpeg to processing the call recording. Okay, I have saved it. Now let's see. Yeah. Okay, it's already changed to finer. The log level is already changed to finer, so we can try starting to call the contact center.
Welkom bij Ecos on Recycling. Wij helpen u zo dadelijk verder. Bienvenue chez Ecos on Recycling. Nous vous aiderons dans les plus brefs délais. Welcome to Ecos on Recycling. We will help you in a moment.
It's arriving. I'm going to pick the call. Hello. Check. Thank you. So as you can see here, the application uh, run the FFmpeg page to convert the recording into and put it into the file share with some format that I'm not sure what kind of format this is. Is this a bitrate, I guess? Yeah. So this conversion is needed so our dashboard or our web application it's referring to this directory so we can access it to from the web GUI portal. Uh, okay, I will show you how our contact center dashboard look like. Yeah, so this is our contact center. I'm not showing. I will not show to you for all the details, but what we are looking for is the recording. So we already in the recordings page. We can just looking for the recording. Yeah, it's here. So we can try to play the recording. Hello. Check. Thank you. So that's it. This is how the deployment process work on Kubernetes using Git. I'm sure there are many ways to learn how to deploy applications, but I believe Git is still one of the fundamental tools that everyone should learn even today. So that's a basic overview of Git based on my own experience. If you'd like to dive deeper, I have included links to some great content in the description below. And if you are planning to grow your career in DevOps, platform engineering, cloud, or similar roles, I believe it's never too late to learn Git. As technology will continue to evolve and AI will continue to advance, but in my opinion, fundamentals still matter because tools may change over time, but the way we learn and the mindset we build as engineers, those things will remain valuable. Uh, in the next video, I'll share, based on my experience, more about GitOps, CI/CD, and how deployment evolved from traditional server into containerized microservices. So stay tuned. Cheers.